Speed and velocity. So here what we have is again speed being scalar and velocity being vector. Now what is the basic classification is that like say a car is moving and the car is moving at 50 kilometer per hour and it is moving in the east direction. So we will say that the speed of the car is 50 kilometer per hour, and we will say the velocity of the car is 50 kilometer per hour due east. Okay, so that is how you call the velocity and speed. That means in one case you have only the magnitude, in the other case you have magnitude as well as direction. Okay, so speed is a scalar quantity and velocity is a vector quantity. And now these all points are further going to get classified as uniform. Okay, now uniform speed and uniform velocity. Okay, so as long as the car maintains 50 kilometer per hour, that is said to be a uniform speed. That means the rate at which the car is moving or a body is moving, if that rate does not change, then we say that the speed is uniform. Okay, like for example, when you talk about the speed of the fan, for example, okay, so unless you change the regulator, the fan keeps moving at a constant speed. So in this particular case, what is going to happen is, suppose you paint a dot over here. Now this dot is going in a circle, but the speed is constant. Okay, because say for example, after every 1 second, the dot comes over here. So that is called as uniform speed. But that cannot be called as uniform velocity, because over here the direction is this, it's tangent. When the dot is over here, when the blade arrives over there, the tangent is in that direction, the tangent is in this direction over here. So you can see that for a circle, uh, the velocity is along the tangent, so the direction keeps on changing. So this is not an example of a uniform velocity. So uniform velocity would be like, you know, a straight road, and the car is moving with the same magnitude, that is say 50 kilometers per hour, sorry, 50 kilometers per hour, okay, in that same direction. So you have a long road. So till the car changes the direction or either changes the magnitude, the car is said to be in uniform speed, or sorry, uniform velocity. Okay, any question about this uniform speed and uniform velocity? Okay, then we talk about variable speed. Now, what is the meaning of variable speed? Now, when you talk about speed being scalar, we are talking only of magnitude. So when you talk about a straight road and there is a car, okay, so say for example, something like, you know, between one signal and another signal. So your car has left one signal and it is speeding. Okay. However, there is a speed breaker. So the car slows down. Okay. There are some potholes. Your car will slow down. Again, it will speed up. And then there is a red signal over here. Again, the car has slowed down. So students, what has happened over here is that the car hasn't changed direction, but it has continuously changed the speed. Now that is an example of variable speed. And that is also an example of variable velocity. Do you follow this? Okay. So that is a direction, that is an example of variable speed as well as variable velocity. Okay. Now, what else can be classified? This example which I gave you of the fan, or which is called as uniform circular motion, that means in this circular motion, the body has constant magnitude of speed, but the direction keeps on changing. So you can see over here that magnitude does not change. However, direction changes. So that will also be categorized as a variable velocity. Okay, this is a very important example, and it is there in the textbook as well. So this tells you that velocity magnitude does not change, but the direction is changing. So it is categorized as variable velocity. Okay, so just to make that clear, I'll just clear this everything. When you talk about variable velocity, so here I'm talking about magnitude, I'm talking about direction. So if the magnitude change and the direction does not change, we say that it is variable velocity. If the magnitude does not change, but the direction changes, still it is a variable velocity, the circle which we saw just now. And over here is when the magnitude is changing as well as the direction is changing, that is also called as variable velocity. Okay, like for example, on a in a street, so the way you have been, suppose you're driving, so you go here, you turn around, you turn here, then go like this. So that means every time you're changing direction and probably you're changing the speed as well. So you need to explain it properly when you're talking about a variable velocity. Okay. For me, one example would be a body which is falling from a height. So this is ground, and you know that as the body drops, the speed keeps on changing. Okay, so a free fall is an example of variable speed as well as variable velocity. Instantaneous speed and velocity. Okay, so when you're talking about a body which is moving and the speed or velocity of the body that is calculated in a very short interval of time, okay, generally it is denoted like this. That means the time interval is near zero. Okay, so this is near zero. That means a very short interval of time. Okay, so that means, that's what the word instant means. Okay, so when you're talking about answer me instantly or instant noodles, like something that you get in shorter time. Okay, so the speed that is acquired by the body in a shorter time is called as instantaneous speed. Okay, now to add to that, if you add direction, so that becomes instantaneous velocity. Okay, students, so something like, if you are in your car and you see the speedometer of the car, so that tells you that how fast your car is traveling. So suppose you look at it and you realize that the speed is 50 kilometers per hour. So you know that the speed right now is 50 kilometers per hour. And to that you add direction. So that will give you instantaneous velocity. So 50 kilometer per hour due north. Okay, so that's instantaneous velocity for you. So this is important term in that. That means the speed is calculated or the velocity is calculated in a short interval of time. Okay, after that, what you have is average speed and you have average velocity. Okay, so for average speed, the formula is total distance upon total time. Okay, and when you talk about average velocity, you're talking about total displacement upon the total time. Okay, so that is called as average speed and average velocity. Especially, for example, you know, if this is a circular track. Now, this circular track, suppose it is 200 meters. So when an athlete starts running, and the athlete completes 200 meters. Now, you all know, students, that if you are running 200 meters, you're not running at the same speed all the time. Okay, initially you take off, you're faster, then you slow down, and then you maintain a pace. And then before the end, you also have, like, you sprint, you cover a distance in a shorter time. So that means your speed is not uniform throughout. So what you do is you do 200 upon whatever time you took. Like, say you took 30 seconds for that. So your speed was something like 6.67 meter per second. But what about your velocity? It will be 0 upon 30. Do you agree with that? Because you started over here and you finished also at the same point. So your total displacement was 0. Okay. So that is average speed and average velocity. So average speed, you take into account the total distance, and average velocity, you take into account the total displacement.